In the last lecture, we said that just based on the probability P, that is the contagiousness of the pathogen, and number 2, by just looking at the number of children every node has, we can comment on whether a disease is going to become an epidemic or not. How do we do that? Let's look at that. Here is a node. This node has some k people, or this node has some k children. Each of these children gets infected with a probability P. This is what we have studied till now. We looked at this number P into K here. What was this number P into K? This number P into K was the expected number of people who are going to be infected here. You can see what is this expected number of people who are going to be infected here. You can see if this node is infected, PK tells us the number of secondary infections produced by one person. Primary infection here, and it creates some number of secondary infections, and that number, the expected value of that number is P into K. This number P into K is very important. It is called the basic reproductive number, denoted by R0, and it is very important because this number is going to reveal a lot of secrets. This number itself is going to tell us whether a disease is going to become an epidemic or not. And I tell you here that if this number R0 is less than 1, let's see what will happen. So this number R0 is less than 1. Recall what is R0? R0 is nothing but P into K, that is the number of secondary infections. If R0 is less than 1, what happens? There are less than 1 secondary infections. If you look at this node over here, it creates less than 1 secondary infection. What does that mean? It is unable to infect even one person here. You see, the disease dies away here itself. And let's see, by hook or crook, the disease somehow survives here. But then in the next iteration, it has a very high probability of dying out. First of all, it dies away here only. Even if here it somehow survives, is able to infect one node, in the next iteration it will not be able to infect even one node. If R0 is less than 1, what's going to happen is, let's take this example. First, let's say P is 0.25, that is the probability of infection is 0.25, and every node is having 2 neighbors, then the basic reproductive number R0 is going to be 0.5. That is, this node here, on an expectation, it is going to infect half of its child, half of its children. Half of its children says that it is unable to infect even one person here, and the disease dies away in this case. What happens? So when R0 is less than 1, your infection ultimately dies away, which means that this contagion is not going to become an epidemic. What happens in the other case? R0 is greater than 1. If R0 greater than 1, we again take the same network, K people, probability of infection P across every edge. And let's say P is 0.25, K is 40. There are 40 people and each person gets infected with a probability of 0.25. The basic reproductive number is 10. So you see what will happen here. This node here will infect 10 people here, and then those 10 people will infect almost some 100 people, and those 100 will infect some 1000 people. So you see how this disease is going to become an epidemic. So in this case, when when your R0 is greater than 1, your disease becomes an epidemic. There is a slight difference between both of these, which is very important. Previously, here, when your R0 was less than 1, we said that infection ultimately dies away, and it dies away with probability 1. It is for sure that this infection will die away. I'm not going to tell you now exactly how. I'll be covering that in the advanced part of this lecture. But you take my words, in this case, infection will ultimately die away for sure. That is, with probability 1, infection will vanish from this network. But in this case here what is going to happen is, your infection, yes, it persists in the network, it is an epidemic. With a high probability it's an epidemic, but still here is a chance that it will die away. So in this case, when R0 is greater than 1, your infection, your contagion is an epidemic, but not with a 100% certainty. There is still a very small probability that it can die away. How it can die away is, let's say at the first level itself, all of these links fail. And the probability of happening that is very small. There are 40 links, and out of these 40 links, each of these links fail. Very less probability, but still it's positive. There is some positive probability that all of these connections fail. And if all of these edges fail if all of these edges fail in transmitting a disease, it means that your infection has died away. So when R0 is greater than 1, with some positive probability, which is high, your infection persists, become an epidemic, but with a very small probability it can die away also. So persists with a positive probability. So I'll write this statement here for you. If R0 is less than 1, then your disease, your contagion dies away. Certainly dies away with probability equals to 1. But if your R0 it is greater than 1, then it persists in the network. It becomes an epidemic. Your infection persists in the network with positive probability. I don't say that this probability is 1, but with some positive probability your infection persists in the network. So we have looked at the importance of the value of R0. If R0 is less than 1, the disease is for sure going to die away. If R0 is greater than 1, the disease becomes an epidemic. Do you see something very interesting there? The importance of this value R0. So here, let's say here is the value 1, and we say that if R0 it is less than 1, your infection dies away. Infection no longer exists. But if your R0 it is greater than 1, R0 is on this side, then your infection is going to become an epidemic. So this value of 1 here, it is becoming so very important. Why so very important? Let's say you have a disease. A contagion is spreading on a network, and let's say the value of R0 is greater than 1. Right? Greater than 1, and let's say this value lies somewhere here. So here is your value of R0. Let's say it is some 1.2, and it means that your disease is going to become an epidemic. Now, you see what's happening. If somehow I can do something here and bring this value a little bit down from 1. Let's say from 1.2, I make this value to be 0.9. Do you see the disease suddenly dies away? So this disease which was an epidemic here, I played little bit with this value of R0, and suddenly this disease will die from this network. Isn't it so very interesting and so very important also? We have looked at R0. What was R0? It was P into K. So P into K is 1.2 here. And I can, play a little bit here. I can maybe decrease the value of P a little bit, or maybe K a little bit. How can I decrease P a little bit? What is P? P is the probability that the disease will attack you. So I can definitely decrease that probability. So let's say a contagion is spreading, an epidemic disease is spreading, viral disease is spreading. I can put an advertisement on TV. I can ask people to take better health measures, to have proper hygiene, and this will, decrease my value of P. So I can either decrease my value of P. Decreasing the value of K is also very easy. What was K? K was the number of people which this infected person was in contact with. So if I can decrease this number of people who are coming in contact with this person, basically what I can do, for some time I can ask this person not to come out of his room. That's called quarantining. So I can isolate this person. So as soon as I isolate this person, the value of k comes down. Either p comes down or k comes down. This value 1.2, even if it get a little bit reduced, it will come on this side of the network and the disease will vanish. And the same thing happens here. Here is a disease and the disease is not an epidemic. But let's say the value of R0 is 0.9. A little bit increase in P or a little bit increase in K can now cause this disease to become an epidemic. So this particular property of this R0 is called knife edge property. It's like the edge of a knife, right? Edge of a knife here. So little bit on this side you come, the disease will vanish from the network, and little bit if there is an increase here a little bit, the disease will become an epidemic. So that is the importance of this value, the basic reproductive number. It very well defines whether your disease is becoming an epidemic or not.